Hello, welcome to the Academy. In today's lesson, we'll be discussing covalent bond. Covalent bond is a chemical bond which involves the sharing of electrons between nonmetals. And I'll be classifying covalent bonds in three categories. Number one, types of covalent bond. Classified based on the number of electrons they share, number of shared electrons. Number two, the polarity. And number three, the coordination of the atoms. So let's look at the first. Number of electrons shared. Let's consider one, the formation of chlorine molecule. Chlorine, we know in the chemical formula CH2. This is the reaction between two chlorine atoms, and chlorine we know is a group 7 element with atomic number 17, which means it has 17 protons and 17 electrons. Reacting to another chlorine atom with also 17 protons and 17 electrons. And with the electronic configuration of their shells, we'll be having the 17 electrons will be in the 2, the K shell, KL, MN, 2, 8, 7. Looking at 17, 2 plus 8 is 10, 8 plus 7 is 17, which means the outermost shell will contain 7 electrons. And this one is also 2, 8, 7. So we draw the shell. Here we have 7 electrons in the outermost shell. Remember, these two inner shells will not undergo chemical combination because they have reached the octet and the duplet stable configurations respectively. So they will be participating in the chemical reaction, the chemical combination, sorry. So we'll have 7 electrons for this chlorine atom and 7 electrons in the outermost shell of this other chlorine atom. Now, each of these chlorine atoms need just 1 electron. Each of these chlorine atoms, the outermost shell, what we call the valence shell, needs only 1 electron to reach the octet configuration. So what do they do? You have 7, I have 7. I'm not going to transfer, unlike in the electrovalent bond where one of the participating atoms will transfer its electron, complete transfer to the next. This one, they are going to have perfect sharing. So what we're going to have is this. Their bond, their shell, they come together in this form. Since I need 1 electron to reach an octet configuration, I'll definitely donate 1 electron. So for this chlorine atom, it donates 1 electron for sharing. And this one donates 1 electron for sharing. Remember, when this releases this 1 electron, it still has 6 electrons. And these 6 electrons will be here. And the second chlorine atom, after donating each one electron, still has 6 electrons. With this, each of these chlorine atoms have obtained the octet configuration of the atomos electron, atomos shell. So let's count 1, 2, 3, 4, 5, 6, 7, 8. For this, 1, 2, 3, 4, 5, 6, 7, 8. So this is chlorine bonding with chlorine to give chlorine. I donated 1 electron, and this other chlorine, I also donated 1 electron, and we shared. This is what we call single covalent bond. Now let's consider the formation of oxygen molecule. Oxygen molecule with the chemical formula O2. Oxygen has an atomic number of 8, which means it has 8 protons and 8 electrons. Reacting to another oxygen molecule with 8 protons as well and 8 electrons. The electronic structure of their shells will be 8 will have 2, the first shell, and the second shell will have 6. Same here, 2, 6, which means that their outermost shell has 6 electrons, and each of these oxygen atoms needs additional 2 electrons to reach an octet state configuration. So let's see them bond. We are drawing the shell, their last shell, or we call the outermost shell. Put the 6 electrons, reacting to another oxygen atom. 1, 2, 3, 4, 5, 6. Now, since each of them requires 2 electrons to reach an octet configuration, covalent bonding involves perfect sharing. You need 2, you bring 2. I need 2, I bring 2. So they will be forming this kind of bond. First, their shells, they come together in this form. Sorry. I need 2, I donate 2 for sharing. 1, 2. I need 2, I donate 2 for sharing. 1, 2. I still have extra 4. And this one as well. So this is oxygen reacting with oxygen to form oxygen. I donated 2 electrons for sharing, and this other oxygen atom donated 2 electrons for sharing. We shared, giving what we call double covalent bond. Now let's consider the formation of nitrogen molecule. With the chemical formula N2. Nitrogen, with atomic number 7, has 7 electrons, okay? It has 7 protons and 7 electrons. Reacting with another nitrogen atom with 7 protons and 7 electrons. Each of them have electronic structure of 2, 5, 2, 5, which means their outermost shell contains 5 electrons, and therefore the each needs 3 electrons to reach the octet state configuration. So we have this outermost shell, 5 electrons. Like I said earlier, perfect sharing. If you need 3, you bring 3. I need 3 to reach an octet configuration. I also need 3 to reach an octet configuration. So I'm going to donate 3 for sharing, and you donate 3 for sharing. So this will be formed. They will have their shell, the outermost shell coming together in this form. I'm donating 3 for sharing. 1, 2, 3. And you bring 3 for sharing. 1, 2, 3. I still have extra 2. And this one has extra 2. So when you count, each of these nitrogen atoms have reached the octet electronic configuration. Where we have 1, 2, 3, 4, 5, 6, 7, 8 in this shell, and 1, 2, 3, 4, 5, 6, 7, 8. So this is a relation between nitrogen and another nitrogen atom, giving us, I donated 3 electrons for sharing, and this nitrogen atom donated 3 electrons for sharing, and we shared. This is what we call triple covalent bond. We have come to the end of today's lesson. I hope you enjoyed the lesson. So do well to subscribe to my channel and turn on the notification bell so whenever I upload the video, you'll be among the first to get notified. Thank you. Until I come your way next time, I remain your favorite online chemistry teacher saying bye.